Hello, class. So, yesterday, we talked about the horizontal spring block oscillator, and we looked at it in terms of forces and in terms of energy, so position and speed. All right, all sorts of fun stuff right here. Bam. Then I said, well, what if we turn it on its side, now making it a vertical block oscillator? First, let's look at it in terms of forces. What if it's not oscillating yet? I just have a spring and I put a block on it. It's going to stretch out. And it's going to stretch out until that moment where the spring force is equal and opposite to the gravity force, which is going to be constant. So X is going to increase and increase and increase until spring force equals gravity force. Which means that the amount of stretch to reach equilibrium is going to be mg over k, dependent on the planet you're on, the mass of the block that you're hanging off the spring, and the stiffness of the spring. All right, cool. Then I said, hey, I want you to now do that energy analysis thing for a vertical spring block oscillator. Here are my answers. All right, I'm going to let you look at it for a second. Compare. Don't just copy them down. Do not just copy this down. I'm going to go over where these came from in a moment. Copy it down then. Right now you're just looking at what you got and comparing it. Okay, so, stuff and things, stuff and things, stuff and things. All right, Mr. Saslow, where did this come from? Well, I'm glad you asked. Oh, before that, I can't remember if I gave you these 4 questions or not. If I didn't, once this video is done, please answer these in terms of this stuff. And if I did, then you've already done that. All right, so where did this stuff come from? All right, so I'm going to jump around a little bit. I am not going to just do one thing, one column, go down, and then do the others. It's not going to work if I do it that way. I'm just going to jump around. All right, just because I'm going to start here, because I know that answer already. We just talked about it, right? The equilibrium position is going to be where the net force is 0. You might want to write that down if you haven't already. The equilibrium position on a spring block oscillator is when the net force is 0. Since there are 2 forces on my block, gravity and spring, when those 2 forces equal each other, that's going to be my equilibrium position. So my equilibrium stretched from natural length, this x, the distance from its natural length to the where it is now, is going to be mg over k. All right, let's go over here. If blue to red line is mg over k, and red line to green line is a, the amplitude of the oscillation, then blue line to green line is going to be mg over k plus a. Ooh. Over here, if blue to red is mg over k, and red to purple is a, then blue to purple is going to be mg over k minus a. Oh. Wow, Mr. Sazzo, it's like you're using logic or something. Crazy. All right, now I'm going to jump down and we're going to talk about h. All right, so if I'm looking at h, and I'm talking about any type of height for any object ever, we, for sake of simplicity, always call the lowest point it reaches height 0. Do we have to? No, absolutely not. I mean, I could call this height 10 meters, and then this is going to be height 10.05 meters, and this is going to be height 10.1 meters. I can do it that way if I want, but since I never go below 10, And I don't really care about absolute energy, do I? I care about the change in energy, so it doesn't really matter. So I'm just going to pretend this is an altitude of 0. If this is an altitude of 0, then that's a height of 0. Here, this is going to be a height of, well, let's see, A. And if this is 0, and this is A, and this is A, then green to purple is 2A. All right. Now I'm going to jump down to forces. Well, we already talked about this one. There's two forces here. It's gravity force down and spring force up, and they're canceling each other out, giving me a net force of 0. All right. What about here? Okay, well, it's compressed, so the spring force is going to push it down, and the gravity force is also going to push it down. Okay, well, so that's going to be spring force plus gravity force. Except that's cheating. Spring force is minus K X plus gravity force. There we go. Now, keep in mind that mg, g is a negative number, right? So this is a negative number. This minus sign here, this g is also a minus, minus the a. This should also give us a negative number. Mathematically, it should just work out that way. If it doesn't, then we need to add a negative. All right, over here, F net is going to be minus, minus K X plus gravity force. Where, in this case, the friction force is going to be up. So this should end up being a positive number, and this will still end up being a negative number. Okay. Now let's look at other things. Let's look at speed. What's the speed going to be at the lowest point? Well, it has to be 0, because it's stopped and it's about to start going up. What's the speed here? Max, but I don't have a number for it yet. What's the speed here? Well, that better also be 0, because it's at the highest point, it's stopped, it's going to start going down. Alright, let's start looking at the energies now. Height, 0, that means gravitational potential energy, 0. Velocity, 0, speed, 0, that means kinetic energy is 0. Speed is 0, kinetic energy is 0. Alright, which means that at this point, the only source of energy is the elastic potential energy, which is given by 1/2 K X squared. Alright, now we have the mechanical energy of the system. Fancy. Alright, let's jump over here. I know that US plus UG has to equal this. Okay, cool. I know that UG is going to be mgh. And I know that the elastic potential energy is going to be 1/2 K X squared. Now, keep in mind what I just said. I just said that this plus this plus this has to equal this. So I could get rid of some stuff if I wanted to. I could say this equals that plus 0, and I could start doing things. Interesting. We're not going to do that right now, though. Alright, and now we're over here. Elastic potential energy, that's still going to be 1/2 K X squared. UG is still going to be mgh. Speed and kinetic energy. Well, we know what the kinetic energy is, don't we? It's going to be the total amount of energy, which happens to be equal to this, minus this energy, minus this energy. Okay, so that's going to be 1/2 k that x squared minus 1/2 k that x squared minus mgh. Boy. This is also, if you remember, equal to 1/2 mv squared. I want to now solve for v, the speed at this point. Okay, so that's going to be multiply both sides by 2, divide both sides by m, and then take the square root of all of it. So, square root of k mg over k plus a squared minus k mg over k squared minus 2mga. Alright. All over m. Isn't that beautiful? Alright, now this looks ugly, and it is. But you just solve for literally every single vertical block oscillator in the universe possible, imaginable. You just solved all the problems simultaneously. So if you can do this from scratch, if you understand the math and the physics enough to do this from scratch, you have nothing to worry about for any vertical block oscillator. All right. So I have a worksheet up on Echo. I want you to do it. There are only 5 problems, and the answers are below, so you can check your work. Please do this in groups of 2 to 4. No bigger than 4, please. And I would prefer if you didn't work alone, unless you just absolutely hate people. Don't work alone. Alright, please pause the video and do the worksheet. When you're done, come back and hit play. You have now hit play. So I need you guys to design me a lab. I'm going to give you 3 springs. I want to know the spring constant for each spring. But here's the thing. Your grade depends on how small your percent error is. That means that you cannot leave this to just one calculation, or even just one type of calculation with numerous trials. No. You need to find me the spring constant using as many methods as you can possibly think of, using multiple trials for each method, and then average all of your answers. Hopefully, if you're doing everything right, all of those answers should be really, really close to each other anyway. Should be. Should be. So you take all of your very close to each other answers for k, you average them, and that is the number that you need to give me. Because that is going to maximize the chance that you'll have a number within acceptable parameters. Questions? Concerns? No? Alright. What I want you to do now, I want you to, in detail, explain to me each method you're going to use to find the spring constant of a spring. Do this in your lab groups, so no more than 4 people. I want equations and stuff. Questions? Concerns? No? Then go.